All right. So we're going to do a little generalizing now, just for you to have for yourself. We didn't put this down first for a reason. I wanted you to try and figure some things out from our little role play that we did. So let's do some generalizing now. What are some shapes that are almost always polar? Here in bent and trigonal pyramidal. This is assuming that the bonds are polar and that there's a dipole. If there's no dipole, the molecule is nonpolar. But that's assuming that the bonds are polar. Those shapes, you can pretty much bet, are going to be a polar molecule. So, bent and trigonal pyramidal. Sorry it erases things when I click to the next slide. It just didn't this in the first place. So bent and trigonal pyramidal are here. I'm not rewriting it. Which shapes are almost always nonpolar? Throw them out. What's that? Trigonal? Planar? More? Tetrahedral I'm hearing. Octahedral. There's one more that pretty much. Yeah. Trigonal bipyramidal. Bipyramidal. You know you don't have one of those on your sheet, like an SH5 or something like that. Which one's iffy? Linear is really iffy. You really got to look at what you've got. You can have polar things like NO or HCl, or you can have nonpolar things like CO2 because it's equal in opposite directions, or O2. So it really depends on what you've got. So linear, you're going to have to kind of analyze, okay, what am I dealing with here? And where are the charges? If they're two identical atoms, you know already you don't have a dipole. It's got to be nonpolar. If there's two equal atoms on either side of the central atom, and it's linear, it's going to be nonpolar. So you really got to look at what you've got and think about, is one side positive and the other side negative if you have a linear molecule.